With this one, what I did on your handout is I just gave you the same integral table that's in the textbook. And if you look at the covers of any calculus book, they're just bombarded with all these formulas for integrals, okay? Tons of them. So I think like the first 3 pages of your handout is like all of these integrals. I don't even remember how many of these are in your book. I must go all the way up to like about 108, okay? So I expect you to memorize all 108. No, I'm kidding, okay? I don't know many of these. I know some of them, okay? All right? That'll be your test in 2 weeks, okay? You're going to just spit out these 108 integrals. Okay, so what we're going to learn how to do is just kind of, if you have an integral, sometimes you have to look at a table, so you have to kind of find the one that matches your integral. So what I did on this, and the way I generally test over this, is I usually, to save time, because you're under time pressure and everything, I give you an integral and I give you an abbreviated table with maybe like 5 formulas instead of 108, so you don't spend all your time looking for the right integral. So I might just say, okay, here's an integral, see if you can use this formula. So really what you're doing in this section is you're just using the formula, and sometimes it's very straightforward. Sometimes you have to use substitutions and techniques and so forth like that. Okay, so here's one that I want to look at a little bit. So the integral table has a formula for the integral of an inverse cosine, okay? And the integral table just gives the integral of the inverse cosine is equal to this. So this one, of course, is very straightforward. Sometimes you're doing an integral, you don't know the methodology to integrate, so you go to your table and boom, you got the answer like that. So the answer to this problem is whatever this says. That's x inverse cosine of x minus square root of 1 minus x squared plus c. Problem done. That's usually not that easy, but one thing I want to also show you on this problem is, we haven't done this a lot of times because of the time constraint on this, but just for this one I want to go ahead and let's do the derivative of this because it's a worthwhile activity to go through. Let's take the derivative of the answer. I'm going to write that square root is 1 minus x squared to the 1/2. So let's do the derivative of that and see what we end up getting on that then, okay? One thing that you want to remember on here too, this is something that you usually do in Calc 1, is the derivative of a inverse cosine is of x is equal to negative 1 over square root of 1 minus x squared. That's something that you may not remember, but that's the derivative formula for an inverse cosine. It begins with c, it's got a negative in it. That's the way I look at it like that. Okay, well let's go through and let's do the derivative of this and just kind of see where this leads us then. Okay, so if I do this, you'd have to do a product rule here. So that's a product rule. And then of course this would be like a chain rule like that. So let's do that derivative just kind of for review. So if we do this product rule, we would have the first times the derivative of the second. The derivative of the inverse cosine is negative 1 over square root of 1 minus x squared, like that. Then do it backwards, plus inverse cosine of x times the derivative of the first. The derivative of x would just be 1 like that. So that's your product rule right there, okay? All right. Now what I want to do from here is we're going to do the chain rule on the next one. Let's just see if we get the integral that we started with anyway. So I'm going to now do this piece right here. So that is minus 1/2, 1 minus x squared to the negative 1/2, and then you got to do the derivative of the inside part, which is negative 2x like that. Okay, let's just kind of see what cancels and see if that doesn't take us back to the beginning of the integral. Okay, everybody with me on that derivative? Okay, that should be easy stuff by now, hopefully. So what I've got here is I have a negative x over square root of 1 minus x squared. This is an inverse cosine of x. Okay, right here I notice the 2's crossing out, and I also have a negative times a negative, so that's a positive. And then I have that x right there. You got to look at this the right way. And then this whole thing right here could be brought down to the bottom. I'm trying to do this all in my head. And then it could be changed back to a radical. You guys see that okay in your head? Okay, 2's cross out, left over x, negative times negative is a positive. Now what happens? Okay, it checked. Okay, all right. So that's kind of the idea. So just as a reminder, you can always tell you're right by doing a derivative like that. Okay, so that's real simple. Sometimes you encounter an integral, you don't know how to do the integral, and you can look it up in a table. Okay, that's one way to do that. That one's straightforward. Okay. Okay, now the next one of the things you do when you're doing when you're looking at an integral table, the integral tables are generally kind of classified in a certain way. So you don't just randomly go through and look at stuff. What I was going to show you on the previous pages here is we have, this is kind of an integral that involves ax plus b. It has a linear term somewhere in it. So all these things have an ax plus b in it. So what I did on this integral, when I looked at my integral table, is I tried to find something that matches this. So what I found is, whereas I have 2u plus 7, they have ax plus b. You have a u in the numerator, they have an x. So that matches that structure right there. So when we work out this integral, first thing you would do is you just bring out the 3. So you would have 3 times the integral of u over 2u plus 7 times du. Now what you do is you just follow what that formula tells you to do. So what you have in this case is, okay, where you see an a is the number in front of x, or the number in front of your variable. So that is your a right there. A is equal to 2. Okay, b is this number. So that's going to mean that b is equal to 7 like that. Okay, then the nice thing about this problem is you just plug in what you're supposed to plug in and then you're done. So if you look at your formula, a is 2. So you're going to plug in your 2 there. Everywhere you see an a, you're going to put in a 2. B is 7. So everywhere you see a b, you put in a 7 like that. So it's just straightforward substitution is what you're doing with that then. So it looks like the answer to this integral then is going to end up being x over 2 minus b, which is 7, and then 2 squared is going to be 4. Then you have the natural logarithm of ax plus b. A is 2, b is 7, plus c, and then that should be the answer to that problem on there. I think I missed something. No, I think I'm okay. Okay, I got b is 7, so I've got everything on there. Okay, now I didn't do I got to do my u. I've got my variables wrong on here. Okay, so I got to match up my variables on here like that. Okay. And again, I'm just following exactly what that integral tells me to do. Now, I did forget one thing. This is one thing you've got to be careful about. So does everybody see how I plugged that in? Now, that's a, right? A is the number that's in front of you in this formula. B is this other number right there. So I do that. What did I forget to do? I forgot all about that 3. Okay, so I do that. Don't worry about multiplying the c by 3 because that's an arbitrary constant. So you should get 3u over 2 minus 21 over 4 natural logarithm 2u plus 7 plus c should be your final answer to that integral like that. So see, that's pretty straightforward. Find the integral that matches yours in the table, then plug it in. You're just doing a formula. Usually that's pretty easy for students. What do you think? Okay. Okay. Now sometimes you have to do, there's times when you have to do some u substitution. This one also I think might be pretty straightforward. This one's a little bit harder to work out because it's got some arithmetic issues in it. But the key thing that you want to see on this is this integral matches that structure, doesn't it? I mean, it's like matches that perfectly. So you just need to know what everything is. A is going to be in this problem. That's going to be the A right there. Okay, so we have A is equal to 4. Okay, B is going to be that number. So that number right there is going to be B. Okay, that's the first thing you got to do is just make sure that everything matches. Then you're going to do exactly what this formula tells you to do. So I'm going to zoom on this a little bit so I can see this a little bit better. So I'm just going to straightforward go through and plug everything in on that, and we'll probably have quite a bit of arithmetic to do on this. Okay, so what I'm going to end up having here is this is going to be 2 over 15, and then a is 4, so we're going to do 4 to the second like that. Okay, then the first parenthesis I got 3ax. Now t is the variable, so you want to make sure that you use t for your variable in your original integral. So we're going to have 3 times 4 times t minus 2 times b. b is 12. Okay, and then over here a is 4, so that's going to be 4t plus b. b is 12 to the 3/2 power plus c. Okay, so I just plug in stuff on that one. I know what a is, I know what b is. Now I do have to do a lot of work to simplify that. You don't want to stop there. You want to do whatever simplification that you can on this. So the rest of this becomes an algebra problem. Okay, so let's see what we have. This is going to be 2 over 15 times 16. Now you could take your calculator and multiply that out if you want to. I'm not going to, because I have a suspicion that something's going to happen with factoring. This is going to be 12t minus 24. Okay, and then this one, I'm going to write that as a square root. What that really is that's the square root of 4t plus 12 with the whole thing being to the 3rd power. Okay, that's one way to look at that, is like that. So we're just kind of applying basic algebra techniques when we're doing this then. Okay, so I've got 2 over 15 times 16. I have a common factor of 12 that's going to come out of there, and then that's going to cancel with something. That's why I left that out as not multiplied. So that's going to be times 12 times t minus 2, like that with the factoring. Okay, now under the radical, what could you do under that radical? You factor a 4 out. That's important too. So we're going to have a 4 times t plus 3. Then that whole thing is to the 3rd power like that. Okay, we still got quite a bit that we can do on this. So what I see with this is you can reduce 12/16. They both divide by 4, so that would be 3/4, like that. And then notice the 2 and 4 reduce too. So I just try to reduce as much as I can. That reduces to a 1/2. Okay, so now what that's going to be is, well, I guess that reduces again. You can do whatever you need to do as a student on this. So you could also do this, and I don't know if you'll follow all this mess, but 3 over 15 is 1/5. Okay, so what I'm left with is 1 times 1 over 5 times 2. So that's 1/10. Okay, stuff like that, if you need to go to the side of your paper and do that, you can. Okay, you can always do that. Really what you had on this is I just kind of reduced until I can't reduce anymore. Okay, so then that's going to be a t minus 2 there. Now, what can you do with this radical now? There's one thing. Square root of 4 is 2, right? So that comes out of the radical. So you can go ahead and do that. See, the whole thing is cubed. But before you cube that, what you could have is you could have, that comes out of the radical, so that's 2 times the square root of t plus 3, all to the 3rd power plus c, like that. Okay? Now, there's a couple of ways you could write the answer on this. So you could write this as 1/10 t minus 2. You want to go ahead and take that 2 to the 3rd. So that would be an 8, like that. And then you would still have that t plus 3 all to the 3rd power, like that. And then there's a couple of things you could do. There's a couple of ways that you could write a simplified answer. You could go ahead and reduce that, of course, to 4/5. That's important to do that. So we would have 4/5 times t minus 2. And you can leave that radical alone. If you want to leave the radical that way, you can. I don't care. But you could also write this as t plus 3 and change it back to a radical form as 3/2. Although that's optional, you wouldn't have to do that. So that would be kind of a nice, simple way to write the answer to that problem, is like that. Okay? So, I mean, the first step was just find the integral in the table, get all the numbers plugged in, and then most of the work was arithmetic. That was mostly arithmetic on that. Okay? Does that look okay? Okay? All right? So that would be kind of how you do that. Let's do probably one additional thing here. let's do this, this next thing. And let's look at this example next here. Okay, so with this one, let's finish up with this one. Let's see what we got going on now. This is one more that I think is pretty straightforward. So if you look at this one, we've got a v, you have an x. It's just the variable's different. Okay, that right there is going to be the a part right there. Now see, that is a squared. That's, a is not 8, a squared is. Then this is just your variable like this. So really all you do on this is you identify a. Okay, so what we have is a squared is going to be equal to 8. And then we're just going to plug in to this formula, simplify, and see what we have going on this then. Okay, so when we plug in, it looks like you're going to have, so everywhere you see a squared, which that shows up 2 places, you're going to plug in an 8 there. That's all you're going to do. So you're going to have 1 over 2 times 8, like that. Now, don't use x squared, use v. Your variable is v. That's your variable, so you want to use v to the second. And then a squared, again, is 8. So that would be 8 plus x squared plus c, like that. You aren't going to get much, not x. You got to be careful about little stuff like that. So you're going to have the v squared there, and it looks like the answer is going to be 1 over 16 times the logarithm of v squared over 8 plus v squared plus c, like that. Very straightforward, okay? So when we get into a testing situation, what I tend to do, partially to save time, I'm just trying to see that, number one, that I give you a tiny integral table with like 5 formulas, and then you narrows it down a little bit, and then I just see that you can apply the formula. That's the idea. So you'll be able to do that pretty easily, don't you think? Okay. All right, well, let's go ahead and stop there for today then, and we'll pick up on this next time. You also want to bring